Maybe they just douse everything in Yeti scent, and then the polar bears know that stay away.
Don't mess with
been
Yeti.
claimed already.
Yeah.
So
Is that where the Yetis are in Alaska?
We don't really know.
Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the Uptime Podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the Uptime Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's episode, first we'll talk about wind turbine wakes and whether some new studies regarding this and new technology tracking it will be able to save millions for those with wind farms, including some of our farmers here in the Midwest. Obviously, the wake produced by a wind farm is a significant variable for other wind turbines in the formation. So we'll talk through whether that could really improve efficiency going forward. We'll talk a little bit about Alaska and the value of wind energy there, and then we're going to talk a bunch about stocks. There's a lot going on, obviously, with the turn of the new year here and a real recent plunge here in the U.S. In the stock market. So we'll talk through some of the new financial guidance and what we see for the future and whether these supply chain issues will continue to persist and push some of these stocks even further down. So before we get going, I want to remind you, sign up for Uptime Tech News, our weekly newsletter and podcast update. If you want to stay on top of everything wind energy, definitely sign up for that. You'll find it in the show notes and Rosemary's YouTube channel. She continues to put out great content each week. You'll find sign up links for that as well in the show notes. So, Rosemary, let's start here with wakes. Obviously, this is something that it's hotly debated with vertical axis wind turbines, maybe more so than horizontal axis, but it affects both of these wind turbines the same. I mean, what's this new focus on wind turbine wakes, and how could this save so much money?
Yeah, so I mean, the loss of energy in the wake of a wind turbine, it's non-negotiable. That's something that's definitely going to happen no matter what kind of wind turbine that you have here, whether it's horizontal axis, vertical axis, or some other kind of futuristic wind turbine. The point is that you're taking energy out of the wind and converting it to electricity. So there must be less energy behind it. And for on that very basic level, this is not a surprise to anybody who's worked with wind energy, ever in the history of them. We've always known that.
Real quick to sum this up, for those who aren't familiar, this is if you took two wind turbines, put them one right in front of the other, say the wind was blowing 20 miles per hour. As that wind goes through the first wind turbine, pushing the blades around and producing energy, it's going to reduce that 20 miles per hour of wind to some lower number and just have less energy to push the second turbine. Is that an accurate depiction of it? Yeah,
so a modern horizontal axis wind turbine take out a little more than 50% of the energy in the wind, but the one behind it won't see that full loss because there's a lot of mixing from outside air. Some wind comes around and combines with it. So yeah, if you put them really tight, close, packed together one behind the other, then you would see less and less energy the further back you go. And that's the reason why, if you look at a wind farm, they're quite spaced out. Usually you'll put 5 or 6 diameters between them so that there is enough space for the wind to recombine and give a decent wind speed for the one behind. Yeah. And I think that this new research is a lot about trying to do it smarter than that. So instead of just putting, heaps of space in between wind turbines, how can we understand how the wake is behaving, how much energy is in it at what point, so that you can try and pack them closer together. So you could use less land and still get an efficient use of each turbine.
When we see pictures of wind turbines being deployed offshore, they're in this grid pattern. It just seems like there's one wind turbine in front of another. That's not the way they would do it, right? I mean, you wouldn't put on an XY grid and evenly space them out. That would seem like that'd be your maximum amount of power loss doing it that way. How do they determine where to space these turbines?
Well, if they're lined up in a grid in rows, parallel with the prevailing wind direction, then you're right, that would be the dumbest way to arrange a grid. And often when you see these studies about wind farm losses, and especially the ones that refer to vertical axis wind farms being better, that will be their comparison case, like the literal stupidest way that you could design a wind farm. But I mean, onshore, the wind farms, the wind turbine locations are irregular because they're micro-sited. So, they have to take into account every small bump, every small hill, a bit of forest, because that really affects how the wind flows around the obstacles. But offshore, it's flat. So I think you would see a more regular pattern offshore, but they won't be just lined up one behind each other in the prevailing wind direction. That would be incredibly stupid.
Could they just use height to counteract some of these challenges offshore? Just make the front row, 400 feet tall, the second row, just increase the height of the pylon so it's the same turbine sitting at 500 feet tall, and the back, just make it like a movie theater so they could all get their good view of the wind.
You can do that, but people usually don't, and it's mostly because you just get such a huge benefit from going up higher, because of wind shear, the wind speed increases with the height
so you want to put them all
above sea level.
As high as they could anyway.
Yeah, you put them all as high as you can, because you get more benefit from that than you might gain from, putting some lower, because it's lower, it's out of the wake, but it's also seeing a lower wind speed to start with. So overall, people are nearly always using the same height tower across a whole wind farm.
Okay, so then if you stagger them horizontally, obviously the turbines are going to turn slightly left and right to capture the wind properly, right? They want to align themselves with it. Is that where some of the issues come in, where even if you stagger them and they theoretically shouldn't have conflict at all, because, row one is, like a checkerboard pattern with row two, and then they're very far, directly behind the next one. But if each one's pitching a little bit different, now do they start to line up again and in a negative way?
Yeah, you've kind of highlighted what's the complicated part. And the wake, it's kind of roughly understood how wakes work, but the real specifics of it, it's not that well understood, especially when you've got different wakes interacting with each other and you've got complex terrain. So that's why there's still, at least 10% gains to be made by getting smarter about this. And you can actually do things like complicated things like wake steering, where you don't just move the turbine to optimize the power that it sees. You think about the wind farm as a whole, and you change the direction of some of the upwind turbines might yaw to be in a slightly less than optimal wind direction from their power production point of view, but that means you can steer the wake away from a turbine behind it. So it's getting more power, and now the wind farm as a whole is optimized. So that's a really promising ongoing area of research where we're starting to see wind farms using these techniques and seeing big gains. And I think there's still more to go, but it's really cool because it's, it's free extra power. It doesn't really cost too much to get smarter about the way you're operating.
Rosemary, what are the costs, though? There must be some sort of negative side to doing this. Is it structural? Like you start yawing into the wind sideways, is it change the loading on the blades?
It would, but if you're, for the most part, you're making them produce less power so that there will be less loads for the ones on the front. So I don't think it's a big structural problem, although definitely it would need to be considered. But I think that the biggest cost is going to be for all the control engineers and data scientists that you need to get working on it. So it's a cost, but I think it's more like of an upfront cost figuring out how to do it, and it probably to some extent needs to happen on a site-by-site basis. I don't think that, GE or Siemens is going to figure out, this is the algorithm that we use now to have a, optimized wake-steered wind farm and then roll it out around the globe. I would expect that you would see, you would see it have to be reproduced in most sites.
And so, Alan, this project, this new research project, the Awaken project, they're trying to really understand these wakes, not just on like a micro level, but potentially up to, 20 miles downstream? Yeah. Am I reading that right?
Yeah, they are. I mean, and the only reason they can even look at it today is because the CFD software has gotten powerful enough, and the computers are powerful enough to try to run that, because they're looking at sort of tip vortices and all the turbulence that comes off the blades in front of the next turbine. That's a complicated set of equations. And if you start looking at hundreds of turbines and pretty soon we're talking about thousands of turbines offshore, you can think about how complicated that situation can be, because you're not looking at it as just one wind direction. You're looking at it probably multiple sets of wind directions and amplitudes, and even times a day, right? So pressure density will change. So there's a lot of variables there. And we do some CFD analysis in-house here, and that's one of the things. It's like it takes a lot of horsepower to do these CFD analysis. So if you're doing 100 turbines, you're going to need someone like NREL, someone who has the supercomputer to do it. Just because, and I think Rosemary's right, you're going to have to instrument, really, with the solution is to instrument a bunch of turbines and then process all that data and then try a couple of different feedback loops to see if you can optimize over time. I don't think, Rosemary, maybe I'm wrong, you're just not going to get handed a set of equations. You're going to upload them to the turbines and away they go. It doesn't seem like what the answer is here. It's a more of an iterative approach or an empirical approach to solving this problem.
Yeah, I think they'll get faster at it, as they learn in the first few wind farms. And I think in the article that I read, they're using a lot of instrumentation as well, like physical measurements and drones and stuff to actually look at what's physically happening. Because obviously, CFD model on its own is not going to give you good confidence. But I do think it's going to be really important with offshore wind, especially because you've got a big area of the ocean, and you want to know how close together you can put the wind farms, because, one developer might put in their wind farm and have their business case based on what they expect to get from it. And then, in 10 years' time, if someone builds a wind farm just upwind from you, then that might have a huge impact. So I do think that, in the future, as, wind has to expand so rapidly over the next 10 years, we are really going to be more concerned about how close together we can put wind turbines than we have in the past, where they were just going on farmland and it wasn't so relevant to get, the very maximum kind of energy density of a surface area.
So in the first steps of the Awaken project, it sounds like you mentioned, Alan, that they're using laser and radar beams. But then in the final step, they're going to use specialized aircraft, and they're going to fly sensors from plant to plant, because that's going to give them additional range. I don't understand what that looks like. Do you understand what that means?
No, I read that, and I didn't understand the purpose of the airplane. To me, maybe it's less expensive. Maybe it's easier to do it that way, because LiDARs are not cheap. You don't necessarily want to instrument every turbine with a LiDAR, but maybe you do. And there comes a megawatt size plant, and maybe it's 8 megawatts, 10 megawatts, 15 megawatts, in which the LiDAR is inconsequential to the cost of the turbine, but the power output benefits totally pay for the LiDAR. So you may start seeing LiDAR become common equipment just to solve that problem. The question is, how do you get the data back? I think that's the bigger question, because you're talking about terabytes of data out in the middle of the ocean. There's no internet in the ocean. So maybe Elon Musk is going to make a fortune on, the upload downloads to all these LiDARs, because there's really no way to do it. I think it's the problem, right? Is how do if you're going to take all this data, you have to have some way to process it and understand it. But you're talking about literally terabytes of data daily of information. And that's the limitation. It's not that we don't have the computing power. It's just where are you going to put all that stuff? Jeff Bezos will make a fortune on the AWS servers, probably.
Well, moving on and sticking with wind speed, we're going to talk a little bit about Alaska. So, Alan, it looks like Alaska has some pretty good offshore wind average speeds. So they've got some areas that get, well above that, like 8 meter per second. I don't know if that's a threshold, but very comparable to a lot of what you see over in California offshore there. They have a number of sites that get above 9, 10 consistently at 90 meters height. Alan, what is your thought on Alaska? Is that going to be a realistic place to put these, or is that environment going to be maybe not worth the trouble, considering what we talked with Dr. Who about, the combination of cold and potentially pretty wet.
Yeah, the winds aren't bad off the coast of Alaska. The issue for Alaska is there's a lot of small communities that are remote that you can't get to in the wintertime except via airplane. And in order to keep the light and whatever heat they have on, they bring in diesel. They fly in diesel all the time. In fact, I've worked on some projects for Alaska diesel delivery. And you don't really think about that in the States because, you just turn the heat on. Everything's delivered to you via pipe or transmission line. In these remote places of Alaska, that's not the case at all. And having an alternative energy source like a smaller wind turbine can make a big difference on how much diesel you need to transport, ship, burn at these remote communities. And I think that makes a lot of sense. I guess the question for Rosemary is it really possible to put wind turbines in such a harsh place reliably? Because if you're not going to have the diesel delivered, you really need to have that wind turbine work. Is it even really possible in these really cold temperatures and remote locations to just is it high enough reliability?
Yeah, I mean, they've got the diesel generation in place now. It's actually the perfect kind of place to move over to a renewable microgrid, and it's something that I've been doing a few projects on in my work recently, helping communities or businesses understand what kinds of generation and energy storage would suit their particular circumstances, because it is very local. I mean, obviously, like you say, Alaska's got problems with the challenges with the cold, but the fact that they're using diesel generators now is it's a good starting point because diesel is really expensive, and so you can get really fast paybacks, really huge economic benefits. If you've got a semi-decent renewable energy resource, then you don't need to replace all the diesel at once. It's not a matter of saying, okay, we're going to, throw the diesel generators into landfill and switch tomorrow to 100% renewables. You would first of all do the easy parts first. So you'd put in some wind turbines that, probably you would size that to have the peak around about what the load is in the community where you're using it, and you just displace as much diesel as you can, and that will give you a really, really fast, really nice payback. And then from there, you can gradually add more and more generation, and then you're going to have to also start to add some storage if you get a lot of wind to be able to supply on average your needs, and you just gradually phase out the diesel. And I would probably leave some diesel generation capacity there for the times when, maybe you've got it there in case you have a weird 2-3 week period where you have very low wind speeds, or if you've got some unanticipated icing event that shuts down all your wind turbines, then you would have a backup. But, any electricity generation system needs some redundancy and some, different different forms of generation. Otherwise, diesel generators, they have unexpected maintenance requirements too, or, anything can. So
sure.
Yeah, I think it's a really good place.
So it sounds like distributed wind and smaller commercial turbines, more so onshore than offshore, is probably maybe the future solution for some of these microgrids.
Yeah, I think so. I don't think you would worry about the complexity of offshore, and being one of the early test beds for a new technology. If you're small, that doesn't make sense. In a decade, then maybe we'll be at the point where it's no big deal to roll out an offshore wind turbine. But if there's lots of space around, which they almost by definition is, if you've got a microgrid, then you probably got no reason not to put in an small onshore wind farm.
Well, I imagine the window in which you could install these is probably pretty narrow, right? Just because seasonally, there's so much snow on the ground part of the year, or a large chunk of the year. And then when that's thawing out, the ground's probably too soft to build. I mean, Alan, is that?
Yeah, what I've seen in Alaska, it's kind of transitions from frozen to mud to frozen again. It's not the easiest place to live in. Yeah, just face it, it's just a difficult environment, but people love it. And if we can get some renewable energy up there and then that's fantastic. I just, the thing that worries me about it all is we don't necessarily design equipment of any kind to to survive in Alaska. It's one of those rare exceptions, right? We designed it for the 95th percentile case. Alaska is that last 5% for most things, in temperature variations, snow, polar bears, the whole thing, right? And elk, reindeer, whatever else. So you have to worry about that stuff. And Rosemary, I thought about you the other day because there's some pictures on LinkedIn about goats and kangaroos hopping on solar panels. I thought, oh my gosh, this is just like Alaska, right? Because you just can't control the animals. And all it takes is, one polar bear to push over a wind turbine, and that would be that. And so it's just one of those weird things. Like, you have to design it.
Is that a realistic thing that can happen? Are they big enough? Are these small enough for that to happen?
The wind turbines I've seen
it sounds great.
Wait. The wind turbines
I'm into it.
The wind turbines I've seen in Alaska have not been megawatt size. They've been lower kilowatt size because it just, in these smaller communities, they don't use a lot of power. They just don't. And so the wind turbines don't tend to be like what you would see on a small American farm. That's what you would see up in Alaska. And because the cost is lower too. So it's sort of an economic play. And yeah, that's what I wonder. Like if I spent, $50,000 on a wind turbine, would it survive the season? That's a really good question because I don't know.
But a lot of those issues are things that they have to deal with all of their infrastructure that's in place.
Yeah.
Obviously, like every time they pour a foundation, they know what time of year they can pour a foundation and what they have to do differently. And I mean, I know lubricants don't work the same at those temperatures. Even my brother's in Montreal, and when he moved there, he's like, oh, my bike chain lubricant is solid in the wintertime. Okay, that's interesting. Everything, you're right that it changes everything, but on the other hand, people have been living there a long time and they're probably already quite used to what sorts of changes need to be made to make it work in Alaska. And I don't know if it's true that the conditions are so extreme that they're not fitting into the cold weather package that wind turbine manufacturers offer, which usually goes down to minus 30 degree operation and a bit lower for survival temperature. If it doesn't survive that, then they would need separate designs special for Alaska, and I would assume some local experts would work together with the manufacturer to find something that would work. But I definitely don't think it's like an abnormal engineering challenge. Maybe it will add some cost to the first generation, but no reason to stop them going down that path in the long run.
Maybe they just douse everything in Yeti scent, and then the polar bears know that stay away.
Don't mess with
been
Yeti.
Claimed already.
Yeah.
So
is that where the Yetis are in Alaska?
We don't really know.
They're wherever they want to be, and they don't want you to know where they are. So need to know basis. Moving on, let's talk about GE Energy. So they've had a pretty rough year, as they've reported a $795 million loss in 2021, which was in stark contrast with a pretty darn good year in 2020, as the company's been slowly turning around and also changing. Alan, they've been hit by obviously supply chain woes, as everyone has, which we'll discuss, but what sticks out as being the real pain points for GE, and how do you think they're going to fix them going forward in 2022?
Yeah, with the breakup of GE happening, I wonder how much work they're going to do to stabilize the renewable energy piece of that company, because they're all headed to really three separate divisions: healthcare, aviation, which is basically jet engines, and power. At least I think those are the three, right? Those are the three. So the renewable energy sector part of it has been, over the last year, just struggling a little bit, and their book orders for 2022 are not where I thought they would be, interestingly enough, and that makes you wonder what's happening. Is it just because GE is pulling back, going to be a little more cautious? They can't overextend themselves as they transition to a separate entity, conserving cash sort of scenario, which it may be. Or is it just an indicator that the market is slowing down, that the unknowns of the supply chain are starting to spook investors and buyers to the point where they need to take a 6-month detour and figure out where the economy is going to be? Because these are, as Rosemary knows, these are sort of long-term projects. Like, you pay for the project, a lot of it up front, and then you make energy 3, 4, 5 years later. In that 3 or 4 or 5 year period, it gets a little scary if inflation's at 10%. I don't know how you even set that up and try to account for it, because it gets super scary. And I think GE's feeling that pressure right now.
Yeah, and they're hopeful to continue to deliver high single-digit margins. And their margins were actually better in 2021, which was encouraging. And it appears they attribute that to being more selective with which projects they take on, not just trying to win every single bid, even if the margin's low, but rather holding back and, saying, hey, this one's not right for us, and going after ones that are more profitable. It seems like it's going to be a difficult road ahead. I mean, Rosemary, what are some of the supply chain issues that it looks like companies will continue to face?
I think it's the same as what you're seeing everywhere. Like the cost of, I was reading an article in the paper on the weekend, the cost of used cars in Australia are up by about 50% because people can't get new cars, so people are buying new. And in some cases, people are paying more for a 1-year-old car now than what it sold for new last year. Like it's steel, for example, chips for cars, at least. I don't know how much of a problem that is for wind turbines. But just so many things like that. We see the same thing in construction. We're having a bit of a construction boom, for residential housing. Prices have gone up 50%, and like timber's doubled, steel's up 50 or 60% or something, and you see just nearly the exact same story that I'm reading with wind turbine manufacturers who are having to go back and renegotiate contracts because the prices for their materials have gone up so much. I read nearly the exact same article about home builders who, they agreed on a renovation 18 months ago, and now it's like, well, okay, the cost of materials is nearly double what it was, so it's going to cost you 50% more for this project. It's like it's the exact same article being written about every single industry, it seems. So I'm not sure that it's so specific to the wind industry. And I know that developers are desperate for more wind turbines. I was talking to one last week who, they've got this they've got a pipeline of multiple gigawatts, and if you look at the amount that Australia is going to need just to replace the coal power plants, which are almost certainly going to close, earlier than expected, there's not enough in the pipeline, and people can't get the turbines to build the projects that they've got committed necessarily. So I think there's going to be a massive crunch in the next few years. It's going to start to cause problems.
Rosemary, on the buying side, though, on the purchase of energy, aren't the energy buyers under that same sort of pressure? Like, they don't want energy prices to jump up without some sort of limitation here. I would see the energy buyers pushing back on the wind turbine side too, and saying, hey, look, you're trying to increase prices on us, which is what's going to happen, and we can't do that. And there's a little bit of give and take here. Does that stall a project because the energy buyers is just saying, hey, there's a limit here, we'll go?
I think so, but I think everybody is just so squeezed that kind of everybody feels that they're being taken advantage of. But on the other hand, everybody's doing it tough because, wind turbine manufacturers are saying to their customers the price has gone up, and it sounds like an opportunistic thing to do because the developer has in many cases no choice to change their manufacturer towards the end of a project once all their approvals are in place. You can't just go back to square one and start again with a new manufacturer. So it feels like, you've got no choice but to do what, Big Wind says. But on the other hand, you look at the profit margins on all of the manufacturers and they're so close to zero and sometimes on the wrong side of zero.
Right.
So you can't say anybody's really, having a great time with this with this supply chain problem.
Yeah, and at some point, you reach. I know you think there's somewhat of a quote unquote free market in energy production and the sale of energy, but there's really not. At some point, there's a government that sits in there and regulates prices to the general consumer like us, and if the price of energy starts rising, I think the local and state governments, and particularly in the United States, will start pushing back and saying, "Hey, look, our economy will not support these rising energy prices, you got to go figure out something else. Do you start to feel that yet? Because to me, it's that murmuring is starting to happen. They can sort of predict the future here. 10%, 10% rate of inflation. It doesn't take long before the average person really starts to get hurt in that.
Yeah, but it's not just energy. It's not just wind turbines. I think it would be hard to single out any one industry as you know, say, oh, you can't increase your prices while inflation is high everywhere. And when you can just demonstrate that their profits are not going up in tandem with their prices, you know. So I don't know. I'm no economist, but I would struggle to see a situation like that eventuating when it's just an economy-wide problem and global problem as well. It's not just, you know, one location or another. It's everyone around the world in any industry is having trouble right now if they need to source physical materials to provide their service.
Well, Alan, can you trace this back? Because I still have a foggy understanding about how everyone in the world has supply chain issues. I mean, it's not like we have less trees than we did before COVID. We have more trees than ever, probably.
Yeah, probably did, yeah.
You know, if we have increasing egg prices, you know, you'd say, okay, well, what's up with the chickens? How much does the feed cost? Well, why'd the feed increase in price? Yeah. Well, the feed increase because of this. Well, why that? I mean, it ultimately goes back to some source. I mean, where is this all coming from? Why is everything becoming more expensive? And
it's sort of a combination of the supply chain has been broken, particularly in the United States, I'd say. There's a huge amount of cargo containers off the coast of America that have not unloaded goods. That creates a shortage. And at the same time, the federal government in the states has poured a lot of cash into the economy, trillions of dollars into the economy. So you have a flood of cash. You don't have enough goods. That's a recipe for inflation. And for whatever reason, I can't grasp yet, we haven't addressed it at all. We seem to be just looking the other way. In the meantime, we have another, maybe the United States is unique in this. So there must be other regulatory bodies in Australia and the UK and Sweden that do similar things. But here it's the Federal Reserve, and the Federal Reserve sets the interest rates between banks, essentially, as banks deal with one another. And they've already scheduled, or at least the plan is to have 4 interest rates this year alone to slow down the economy. The problem is that inflation is still going to rise in that interim. But what will happen, you'll see downward pressure like on the stock market. So people's investments will go down, and you'll see upward pressure on prices still until it all settles out. In the meantime, it hurts like hell. And this isn't the first rodeo that I've been through in this kind of U.S. economy, but it's not fun. It really is not fun. And we're heading into a couple of years struggle. I think we really are. And and I think maybe Rosemary and I agree on this sort of piece where if we think climate is an existential threat, and that's the common belief, I think you're really going to hurt renewable energy. That's when it's going to get hammered because you're competing with things that already exist. And there will come a point in time where states will push back, and the United States will start pushing back and say, we're just not going to do it. And I think there's be countries that are going to say the same thing.
If the cost of fuel is rising as well, obviously, like you might already have a coal power plant or a gas power plant, but they don't have all the fuel they need for the next decade. So I think it's not so black and white about which way it will go, because I mean we have seen just such a huge increase in gas prices, and coal is really struggling, especially in Australia. We had articles just yesterday about everyone is now expecting the coal power plants to close much earlier than they said, because there's just no line of sight to profitability for them in a very short time. Every country is different, right? I think America was energy independent about 6 months ago, and we decided we weren't going to be anymore. So that leads to a lot of concern, right? And so there's going to be a lot of arguments in the United States, like, what happened? Why did we do that? Why did we do that to ourselves? I think there's a lot of countries doing the same thing right now. I think Germany's asking the same question. I think there's many places that are asking that same question of, a year ago, we were just fine. What happened? And how are we going to try to deal with it?
And in the absence of, I think, leadership in the case of the United States at the moment, you're going to get a lot of people stepping into that void. And that's where it gets a little scary.
So one interesting thing that's happening in the market right now with stocks is that a lot of hedge funds are shorting renewable energy stocks. And of course, if you don't know what shorting is or short selling, it's when you essentially borrow a stock and sell it, and then you purchase it later at a lower price, or you hope that it's a lower price. So an example would be, you buy a stock for $100 a share, you're borrowing a stock for $100 a share. You sell that, and then you say it's one share. You sell that one share for $100, and then a period of time later, you have the option to buy that back if it declines, or you hope that it declines. Say you buy it back for $50 a share. Now you've sold it for $100. Now that it's declined, you buy it for $50, and you've pocketed the $50 difference. So you bet sort of the wrong way. Whereas, typical stock trade, you buy it at 50 and hope it goes up, right? So, Alan, a lot of hedge funds right now are betting against renewable energy stocks, and they're shorting them. And part of the reason is, here's one quote from this article in the Financial Times. It says by Barry Norris, Chief Investment Officer at Argonaut Capital. He says, in a bear market, a company doesn't trade at 60 times earnings just because it does something morally good. And we have seen a lot of stocks that are inflated very high above what their actual financial value might be. So, do you see this trend continuing? And that's true. A lot of people, when you think of the stock market, you always think the price is permanently, tethered to the stock price. Like what their revenue is tethered. So it's always a logical. Some people try to argue that the stock market is always logical, and it's clearly not. Right? You hear, and I think Tesla's been a good example. Tesla would rise and fall substantially in a day based on Elon Musk's tweetings or doings. When he tweets at 4 p.m., did the value of the company go up? No, but the stock goes up 5% because people are excited about something he said or something he didn't say or something he alluded or hinted at. And so the pressure of like, oh, I want more of this, supply and demand, the price goes up. But this idea that, people want to own, renewable energy stocks because they do a good thing for the globe, for the world. But that doesn't necessarily mean they're worth what they purport to be. Alan, what's your take on the short selling with renewable energy?
The stock market is basically trying to forecast or fortune tell 6 months out in the future on the economy. That's really what it does. And when you have a number of institutional investors short selling any stock, they're saying that they're betting that the whole thing is going to go down. And based on the numbers right now, if you start looking at the releases, the quarterly releases on their profitability of any large industrial company, maybe except Tesla, they're not forecasting increasing profits. They're saying they're likely to take a loss or just to break even. And the stock market's saying, well, that means that the ability to pay dividends essentially goes to zero. That's what'll happen, and there's no chance of a buyback. And therefore, my value of my stock is less when it's going to be today. That's the problem with inflation. I think that's the huge driver here, that it may seem like we have a temporary bubble because of COVID, but that temporary fluctuation in the economy is really turning into more of a longer term problem. And the stock market is going to start saying that. If you start looking at the stocks for Siemens Gamesa, Nordex, Vestas, even GE in some measure, they're going down. They're going down like 30% down over year to year. That's a huge drop. And it should be sending off alarm bells to investors and to the companies themselves. Like, this has got to get right. And we need to start putting pressure on basically the government leaders that have some say in this to stop the bleeding. Because if they don't, we're going to have bigger and bigger problems. And when I say bigger problems, you could lose a wind turbine manufacturer. And you really can't do that right now. That would be not the right place to be. But we don't. Our view in the United States is totally different from outside the United States, I'm sure. But what it looks like in the United States is that we're just saying, hey, it'll work its way out. That's not historically what happens. that's worrisome to me. And I hope that when the wind turbine community and the CEOs start pushing back and saying we need to raise prices, we need to get the shipping issues resolved, we need stability in steel, we need stability in fiberglass, we need stability on large machinery. That they're not kidding, right? It's thousands and thousands and thousands of jobs that are affected here. It's time to step up and to do something about it. And I just, Rosemary, I'm sure have a different opinion, but I don't see a lot of action right yet. And if we let it sit for another 6 months, we're really going to be in trouble.
I've actually been surprised by this this talk of shorting and the companies that they were talking about, which is, what was it, like Nordex and the manufacturers, not because I have noticed, one, there's been nothing to do with your money over the past few years other than put it in the stock market because, I looked up term deposit rates recently and it's like, oh, you can have 0.1% and we'll lock away your money for 2 years. Well, okay, I'll just keep it in the bank and have that flexibility. So you want any chance at getting a increase, then, you either have to buy property, which is the favorite way to make money in Australia, or you have to put it in the stock market. So I have definitely sensed that the stock market, I can totally get that it is overpriced in general. And I have noticed that everybody is desperate to make green investments and there's not that many places to put your money for green technologies. But I have for at least a decade, I've owned a lot of green stocks like Vestas and Siemens and also just a global wind index and a global solar index. And those have never gone well. They've gone up, but not as much as you would think, given that, I bought all those way before this huge boom in renewables. So that's why I'm surprised to see that these are the ones that are being shorted now. Like, have they really been overvalued so much to start with? And I guess it's, got to do with the fact that those companies are they're really struggling with their profitability right now, even as installations are going up and up and up. But where I do see heaps of froth in the clean tech area is these, brand new energy technologies that have been listing through SPACs. And, there's some energy technologies that are just basically at prototype stage and already listing, and in many cases just demonstrably bad ideas that the physics and the engineering just isn't there for it to ever be a good idea. And you see quite a few companies like that have very high values. And I would absolutely, if I was, into shorting stocks and more, maybe more of a risk taker, then I would be shorting those kinds of stocks for sure, because it's ridiculous. But the problem is with shorting, it's not enough to know that something's eventually going to go down. You have to be able to hold your position until it goes down. So, who can say how long how long this will go on for? If it's years, then even if you pick the right direction, you're still going to lose money. So, that's why I stay away from that. But I have been surprised that the shorting is happening in the companies that are actually making things that people want to buy. That to me is surprising.
Rosemary, I think that it's the most visible indicator, right? They're the most visible companies out there. It's hard to miss GE. It's hard to miss Vestas, right? I think they're the most visible signs for the wind energy side, the most visible companies, rather than the Dominions or the Duke Energies that may be using these wind turbines. The OEMs are very, very visible, and it doesn't take too much of an economist to figure out they have supply chain issues, and you can kind of sense of the price of steel, the price of some of those raw materials going in. We can just check up online and see what those are. We know the economics for those companies is not going to go in the right direction in the next 6 months, year, 2 years. And so it's easy for stock pickers, economists to do the math on an Excel spreadsheet and roughly predict where they're going to be. And they're not going to be too far off. I think it's going to be trouble. And we need, I can't say this hard enough, we need to be addressing something now. And I just haven't heard any real leadership in the United States on this issue yet.
Yeah. As for me, I've been interested in renewable energy. Obviously, the more you know about a sector, the better. And I believe in some of these companies, but I haven't decided to invest. I don't invest in any of them, mostly because of this. It seems like it's just like uncertain waters. Like you said, Rosemary, it seems like, hey, a great time. Like if you know a lot about renewable energy, you're pretty up on these projects. Like, it's not hard to figure out that there's going to be a lot of wind turbines sold and wind farms built in the next couple of years, but it's just not clear that the margins are going to be there and that these are going to be profitable businesses. Whereas for me, and I haven't done much digging here, but I've been looking at some of the peripherals and some of like the vendors who might be selling. Like a good example, and I don't own stock in this company either, is Timken, maker of bearings, right? So you start to think of some of the peripheral parts that go into these turbines, and you wonder, does a company that's selling to a GE or a Nordex, are they in a better position financially? Are they having better margins? Probably. And they might be your sort of way into supporting renewable energy. And again, I don't have any stakes in any of these companies, where that might be a good inroad. It's hard to know, but that's why everyone should do their own research. We're obviously not giving any guidance on what stocks to pick. But it's kind of the Wild West right now because, you've seen stocks go up and down so much recently, especially down here in late January. And it's hard to know whether that's because of legitimate financial forecasts or if that's just because of the irrationality of the stock market and other factors and the fear. Because, how many of us saw the stock market crash back in March 2020 with COVID and the fear that set in? But then you're like 6 months later, you're like kicking yourself that you didn't buy pretty much any stock in the world, right? So this could be just one of those another down periods now. And I guess we'll see when inflation starts to slow a little bit. So last on the docket here today, interesting accolade for Vestas. Speaking of them, they've been named the most sustainable company in the world for 2021 by Corporate Knights. So Rosemary, what does this mean? That's just something that I find it kind of like a nebulous distinction, but I'm sure there's a lot of thought and metrics behind it.
I have been really pleased to see this, kind of shift in corporate culture where in many cases I see that it is the big companies that are leading the way on ambitious environmental outcomes. They're the ones that are paying over the odds for a power purchase agreement for, helping to make new wind and solar developments, financially viable for developers. And you see like Google has their 24/7 green energy project where they're actually doing, a lot of really smart work to reduce their impact and, not just through buying offsets, but they're actually looking at, where and when are we using electricity and how can we shift that so that we can get the highest possible proportion of that green. And I know IKEA in Australia is one of the first adopters of electric delivery vehicles. So, they're helping drive technology for electric trucks. And it's not much more expensive, but it's basically because, I don't know, I felt this way. We've been ordering so much more online during the pandemic, and it does make you feel a little bit gross to think about, the impact of that. So I'm definitely more likely to choose a company that's delivering with clean deliveries. And my supermarket will offer me one window per day where it's a green delivery where they've got an electric truck. So yeah, I have been pleased to see this move. And in Australia, it's definitely a bigger move from corporate than the government towards sustainability. So yeah, no, you're right that it is definitely a pleasing development to see, and good work Vestas. Won the award.
All right. Well, we're going to wrap up there. Thanks so much for listening. We appreciate you. Be sure to leave us a review on iTunes, Spotify, Stitcher, YouTube, wherever you are. And of course, definitely subscribe to Uptime Tech News and subscribe to Rosemary's YouTube channel. Again, both you'll find in the description of this podcast. Thanks again for listening. We'll see you here next week on the Uptime Wind Energy podcast. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. This is why it just makes sense to install a WeatherGuard Strike Tape LPS upgrade the next time your technicians are going up tower. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.